Question 1. Express 5 cos x plus 12 sin x in the form r sin x plus theta. Alright? So, they want us to express 5 cos x plus 12 sin x in the form r sin of x plus theta. Alright? How are we going to express this in this form? There's two things that we need to determine. You need to determine the value of r, and you also need to determine the value of theta. Once you determine the value of r and the value of theta, then it is just easy from there. So I'm going to keep my r, and you can use the addition sum formula to express sine of x plus theta. So sine, this would be sine cos cos. This would be sine cos, sorry. So this would be sine x cos theta plus cos x sine theta. Right? Then you can distribute the r to each term. If you distribute the r to each term, you now have r sine x cos theta plus r cos x sine theta. Right? But remember, if you are expressing something in another form, you are not changing the value of that thing. So that means these two things are equal. It means that r sine x plus theta is actually equal to 5 cos x plus 12 sine x. So if they are equal, we are going to find the exact part that equal to each other. So here we have r sine x cos x. So we have a sine x here, we have 12 sine x, so we're going to write that here. So we're going to write 12 sine x here. We're going to put our plus sign here. And we have a cos x here, so we're going to write 5 cos x on here. So we're going to write 5 cos x. Right? Remember that addition is commutative, so the order does not matter in which we add things. We are not changing. So now, if these two things are equal, it means that this part is equal to this part, and this part here is equal to this part. But note, in this part we have r sine x plus theta. In this part we only have 12 sine x. But note here we have sine x in both sections. So if these two things are equal, it means that sine x will equal to sine x, right? So sine x here would equal to this sine x here. So it means that r cos theta is equal to 12. And we can write that down. So we know, we could say that r cos theta is equal to 12. Could use the same idea for this section as well. If cos x is equal to cos x, then it means that r sin theta is equal to 5. So it means that r sin theta is equal to 5. Right? Now remember, we need to determine two values. We need to determine the value of r, and we need to determine the value of theta. I'm going to try to determine the value of theta first. How can I use this information to determine the value of theta? One thing that you need to remember that if you have sine of x divided by cos of x, which is an identity, this is equal to tangent of x, right? So with this identity in mind, it means that I could divide these two equations, right? So let's divide them. So if I'm dividing this equation, I'm going to take the second one here and say r sine theta divided by r cos theta. Then this is equal to what? What is sine theta here? Sine theta is equal to 5, so this is equal to 5 divided by 12. Hope you follow me there. Here, r will cancel out r, so all I left back with is sine theta divided by cos theta. But sine theta divided by cos theta, that is just tangent theta. So this part is tangent theta is equal to 5 over 12. Now from having tangent theta equal 5 over 12, I can easily find the value of theta. So all I need to do is to just take the inverse of both sides. So if I take the inverse of both sides, I'm going to now have theta is equal to tangent inverse of 5 over 12. And you put that on your calculator. If you put this on your calculator, you will get theta is approximately equal to 22.62 degrees. Right? So we have one part of our puzzle already, which is the theta. So we now know that theta is equal to 22.62 degrees. So the only part of the puzzle that is left is to figure out the value of r. Right? Now how can we use this information to determine what r is? Look at this. R cos theta equal 12 and r sin theta equal 5. These are just two simultaneous equations, right? So it means that we could try to solve them simultaneously. So you can either add or subtract simultaneous equation, right? No, but before we try to solve them simultaneously, it means that if I'm going to try to solve this simultaneously, I need to get rid of this cos theta and I need to get rid of this sin theta. Alright? Now, there's one thing that you need to bear in mind. Right? So I'm going to erase all of this to get some more space here. So, bear in mind that you have to remember this identity. Bear in mind that sine squared x plus cos squared x is equal to 1. Bear that identity in mind. If you remember that sine squared x plus cos squared x is equal to 1, it means that I could now square both sides of these equations, right? If I square this side so that I get a cos squared, and I square this side so that I get a sine squared, I will now have, if I square this term, I will now have r squared cos squared theta is equal to 12 squared, and 12 squared is 144. And I did the same thing to this one. I will have r squared sine squared theta is equal to 5 squared, which is 25. Right? So now I have two equations, and I am going to solve these two equations simultaneously. Now I am going to add them together. Right? So I'm going to add this side to this side and this side to this side. So if I'm adding them together, I now have r squared cos squared theta plus r squared sine squared theta is equal to 144 plus 25, right? That's right, which is equal to 144 plus 25. Now, I can combine this. So 144 plus 25, that is 169. Now on this side here, I have a r squared and I also have a r squared. Remember, I'm solving for r. Now, it means that r squared is common to both terms. It means that I can factor out the r squared out of this side. So I'm going to factor out r squared. If I factor out r squared, I'm going to use r squared to divide each term here. So if you use r squared to divide r squared cos squared theta, that leaves you back with cos squared theta plus, if you factor out the r squared out of the second term, that leaves you back with sine squared theta. Right? And all of this is equal to 169. But look at this part in the bracket. Cos squared theta plus sine squared theta. Here I remind you of this identity. Sine squared theta plus cos squared theta is just 1. So all of this in the bracket is just 1. So what I have here is just r squared times 1 is equal to 169. Now 1 times r squared will just give you r squared. So this is just r squared equal 169. Now how am I going to find r? I can take the square root of both sides. If I take the square root of both sides, the square root sign cancels out the 2 here. So r is equal to the root of 169, which is just equal to 13. So now I know the value of r, which is 13. So if I know the value of r, which is 13, and I know theta, I can just simply now rewrite this. So I'm going to erase all of this. So my final answer is going to be, therefore, 5 cos x plus 12 sine x is equal to r, but what is r? That's 13, so that's going to be 13 sine of x plus theta. But what is theta here? That's just 22.62 degrees. And that's it. Okay? Pretty simple, right? Alright. So now let's look at number 2. So number 2 says, without using a calculator, determine the value of cos x if sin x is equal to 3 over 5. Right? So we want the solution for number 2. Now, I am going to draw a famous identity that you just know. We know that cos squared x plus sine squared x, that is equal to 1. They want us to find the value of cos x, right? But they give us sine x, right? What is sine x? Sine x is 3 over 5. So I can replace this sine x here with 3 over 5 because sine squared x means sine x all squared. So I'm going to write cos squared x plus sine x. What is sine x? 3 over 5. So that's 3 over 5 all squared is equal to 1. So cos squared x is equal to 3 over 5 all squared. That gives you 9 over 25 equal to 1. Right? It's supposed to be plus, sorry. So cos squared x plus 9 over 25 is equal to 1. Now I want cos squared x by itself. So I'm going to subtract 9 over 5 from both sides. So if I subtract 9 over 5 from this side, all I left back with is cos squared x is equal to 1 minus 9 over 25. Right? Now, cos squared x is equal to 1 is the same thing as 25 over 25 minus 9 over 25. Right? How do you subtract fraction? Once the denominator are the same, you keep the denominator and subtract the numerator, right? So cos squared x is actually equal to 25 minus 9, that's just 16 over 25, right? Now how am I going to find cos x. I want to get rid of this squared, right? So I'm going to take the square root of this side, and I'm going to take the square root of this side. So the square root sign cancels out the square, so cos x is equal to the square root of 16 over 25, and that's just 4 over 5. And that is how you calculate the value of cos x without the use of a calculator. Fun, right? Number 3. Cos x plus 20 equal a half. Determine the value of x between 0 degrees and 90. The domain here is key. They say that we must determine the value of x between 0 degrees and 90. That means the angle must fall between 0 and 90. So we know that cos x plus 20 is equal to a half. Right? How are we going to solve this? We're not going to expand this. Right? What we are going to do is to say let x plus 20 equal y. That's inside of the bracket. So I now have cos y is equal to a half. So I can find y, right? Take the cos of both sides, cos inverse of both sides. So y is equal to cos inverse of 1/2. Right? So y here is equal to cos inverse of a half, that's of 60 degrees. Right? But remember, they didn't ask us to find y, they asked us to find x. So now you have to recall. So if you recall that y is equal to x plus 20, then you can replace this side of the equation with x plus 20, right? So that means x plus 20 is equal to 60 degrees. Now we can solve for x. All you need to do is to just subtract 20 from both sides. So positive 20 minus 20, that's 0. So on this side we're left back with x is equal to 60 minus 20, that's just 40 degrees. So x is equal to 40 degrees. And does it fall in the domain? Yes, it falls in the domain 0 degrees and 40 degrees. And 90 degrees, sorry. Alright? And that's it. Pretty easy, right? Question number 4. If sine squared x equal 3 over 4, determine all the values of x between 0 and 360 degrees. So we know that sine squared of x is equal to 3 over 4. So one sine x by itself, we can take the square root of both sides. So I'm going to write back what we have, which is sine squared of x is equal to 3 over 4. I'm going to take the square root of this side, and I'm going to take the square root of this side. So the square root sign cancels out this 2 here. So we're left back with sine of x is equal to the square root of 3 over 4, and that is just root 3 over 2. Now I can solve for x by taking the sine inverse of both sides. So x is equal to sine inverse of root 3 over 2. So x is equal to sine inverse of root 3 over 2, that's a 60 degrees. Right? So x is equal to 60 degrees, but that's just one value of x. They say that we must determine all the values of x between 0 and 360. Which means that between 0 and 360, that's only positive value. Right? Now, how are we going to determine the other values of x? What I am going to do is to draw the quadrant, right? 4 quadrant. So this is quadrant 1, where all sine, cos, and tangent is positive in this quadrant. Quadrant 2, sine alone is positive in this quadrant. Quadrant 3 is tangent alone is positive in this quadrant. And quadrant 4, cos alone is positive in this quadrant. Now, it means that if sine alone is positive in the second quadrant, sine is negative in the third quadrant, and sine is negative in the fourth quadrant. So sine is positive in the first quadrant and the second quadrant. But we have the value for the first quadrant already, which is x is equal to 60 degrees. Now there is something that you need to remember, which we call the associated. Now you need to remember that the associated acute angle are equal, right? So this is an acute angle, so it means that we can use it to find the other associated acute angle, right? Now we know that sine is positive in the second quadrant, right? So what I'm going to do, I'm going to erase all of these for now. And I'm going to represent this problem on the quadrant here. So if I have a line projected from here, let's say that this angle here is my 60 degrees. If this angle is my 60 degrees, where do you think 2 would be? 2 would be here on this line here, which is the hypotenuse. Where do you think root 3 would be? Root 3 would be this side. So sine 60 is equal to opposite over the hypotenuse, which is just root 3 over 2, right? Which means that if this is the initial line, 0 would be here, 360 degrees would be here, 90 degrees would be here, 180 degrees would be here, and 270 degrees would be here. Now, when you are using the quadrant, you measure angle in an anti-clockwise direction, right? You can't measure it in a clockwise direction, but you measure angle in an anti-clockwise direction. So when you go in an anti-clockwise direction, the angles are positive. If you go in a clockwise direction, the angles are negative. Now, if this is the initial line, that's where you start measuring from, we can draw a loop to identify this angle here. Now, up to this line here is 180 degrees. Up to this line where I stop here, that's some angle plus this 60 would give us 180 degrees. So I can easily calculate this angle. So this angle is going to be 180 degrees minus the 60 degrees here, which gives us 120 degrees. So the other angle that falls between 0 and 360 that gives the same result as sine 60 here is 120 degrees. So here x is also equal to 120 degrees, right? And those are the two values of x. So note here that sine 60 is equal to sine of 120 degrees. Sine 60 is just root 3 over 2, which is equal to root 3 over 2 here. So they are both equal, alright? Let's look at, let's look at question number 5. Now question number 5. The cosine of which other angle between 0 and 360 degrees will produce the same as cos 45, right? So they give us a range, and the range is 0 degrees. So we know that x falls between, which is the angle in this case, falls between 0 degrees and 360 degrees. That's the domain that they give us, right? And they want us to determine which other angle between this range that will give us the same result as cos 45. So we know that cos 45 degrees is actually equal to 1 over root 2 or root 2 over 2. Right? Now we want to determine which other angle. Now, how are we going to determine that? We are going to go back to our quadrant, which is this. We know that this is 0 degrees starting going this direction, so it's going to be 0, 90, 180 degrees, 270 degrees, right back to 360 degrees. Alright? We know that cos is positive in the first quadrant and cos is also positive in the fourth quadrant, which is this quadrant, these two. So we can use the idea of the associated acute angle to find the other angle that will give us the same result as cos 45. So now we're going to draw a line here. So this angle here is my 45 degrees, this is it. So now I just complete my right angle triangle here. So here is the 90. So if this is 45, and we know that cos of anything has to do with adjacent over the hypotenuse, right? We know that the hypotenuse here is actually 2. Right? And this side here is actually root 2. Right? Because cos 45 is equal to root 2 over 2, which is thus root 2, which is the adjacent side, over the hypotenuse, which is thus 2. Follow me there? Now, I need to determine the other value of x that falls between this range. So all you need to do is to just measure from the initial line in an anti-clockwise direction, all the way around to this line, which is that angle there. So we know that this angle here plus 45 must equal to 360 degrees. So we can determine that angle, right? So we know that, let's say that all of this angle here, this loop here, that's just x. So we know that x plus 45 degrees must equal to 360 degrees. So we can subtract 45 from both sides. So therefore, x is equal to 360 degrees minus 45 degrees, right? So x is equal to 10 minus 5, that's just 5, right? 5 minus 4, that's just 1. And 0, 3 from nothing, that's just 3. So the angle is x is equal to 315 degrees. So therefore, we can say that cos of 315 degrees is equal to cos of 45 degrees. So therefore, cos of 315 degrees is just equal to root 2 over 2. And cos of 45 is just equal to root 2 over 2. That's it. So that is the other angle that falls between this range, which is 0 to 360 degrees. That will give you the same result as cos 45. Alright? Thank you for watching, and I hope that this video would have helped you in more ways than one.